Alright, this is the second of two parts on data visualization. In this video, we're going to be going over the Pareto chart in particular, and then also some basic tips on how to not deceive with your graphs. It's very easy to construct graphs and plots in such a way that they're misleading to your audience or that they give off the wrong impression, and we want to learn how to avoid those types of mistakes. And common example I think of is this loading bar here. Whenever you're downloading something, usually the bar will go up to 99%, but you know it's not really 99% done. It's going to take 300 years for that last 1% to finish. And so that would be an example of a misleading graph. Now before we get into the Pareto diagram, we're going to have to go over two concepts really quick that we did not go over in the last video on two different types of frequencies. And the first one is relative frequency. And this is when we take each count in our data set and express it as a percentage of the whole. What percent of all the data ended up in that one category? And so we can do this pretty simply. The first thing we want to do is we're going to want to take our 5 numbers here for the count and add them all up so we have our total count to get the whole within the part over the whole. And so if we add those 5 numbers up, we should get 76. And so all of our relative frequencies, we're going to calculate using the number 76, the total amount. And so if we want to get the relative frequency of, say, people aged 0 to 9 in this data set, we can take the count of number of people aged from 0 to 9, the part, and divide by the whole, which is 76. And this will end up getting us about 11%, roughly. And you can also express a relative frequency as a decimal, but here we're going to be doing it as a percentage. And so we can repeat that process for the other 4 counts. 11 over 76 ends up being about 14%, and then 18 out of 76 ends up being about 24%, 16 out of 76 ends up being about 21%, and lastly 23 out of 76 ends up being about 30%. So now we have our relative frequencies for our 5 categories in this data set. And now we can move on to the other type of frequency, cumulative frequency. And so this is very highly related to relative frequency. And instead of just taking the percentage of one particular category in each group, the cumulative frequency takes all of the counts up to and including that level that we're trying to find the relative frequency of. So let me rewrite the relative frequencies for each of these 5 levels in the data real quick. And so when we take the cumulative frequency, what we end up doing is summing up all of the previous relative frequencies. So for instance, 11% of people in this data are aged 0 to 9. So the cumulative frequency will also be 11% for this first group because it's just that group. There are no groups before it. But when we take the cumulative frequency of the age 10 to 19 group, what we are really saying is what percentage of people belong in groups from 0 to 19, 10 to 19 plus all of the previous groups before it. And we can get this cumulative frequency by adding the relative frequencies that we've already found. So in this case, 11% plus 14% gives us 25%. And we can repeat this process. Now for the age 20 to 29 group, we take its relative frequency of 24% and add on the previous cumulative frequency, which is the sum of all of the relative frequencies before it. And so we get 25% plus 24%. And that will give us 49%. And then we can repeat that for the fourth group, 49 plus 21% gets us up to 70%. And then lastly, add up 30% for the final group, and that will get us to 100%. And once you go through all of the groups, your last cumulative frequency should be 100% because it should be taking all of the previous counts before it, which should add up to the total. So you would get the total over the total in essence, which is 100%. Now the Pareto chart essentially takes the four categories of information in this table and sums them all up to put in one plot. So you get all of this information all at once. And it's kind of a good graph to get a lot of information in a small portion of area. And so we'll start by making the basic axes. The one different thing about the Pareto chart is that it's actually going to have two y-axes labels. It's going to have one for this left side and one for this right side. And on the left side, we'll have the count, which is something that we saw in a lot of plots in the first video. And on the right side, we're actually going to have the cumulative frequency. So put C frequency for short here. And so on the cumulative frequency side, we're going to be having it go from 0% to 100% because that is the range of that the cumulative frequency can go. And the count, we'll have to look real quick. The count will go from 0 to 76. Because that was the total amount of data points in this data set. And so with the Pareto chart, we'll first want to make it kind of like a bar graph. We'll take each count and give it a bar that goes up appropriately to whatever count it has on the left side, on the left y-axis. But we want to do it in descending order. So instead of just starting with 0 to 9, 10 to 19, 20 to 29, and so on, we're actually going to start with whichever one has the biggest count, which in this case is 40 plus. And so we'll start with the 40 plus group. And this count goes up to 23. So 23 is probably somewhere around here or so. Here's 40 plus. And then we'll go to the second biggest count, which is the 20 to 29 group. And this had a count of 18. This one's 23. This one will probably be a little bit lower. Say, going up to about here. And then the third group, the 30 to 39, had a count of 16. That one will be right about here, a little bit smaller. And then the 10 to 19 had a count of 11. And then lastly, 0 to 9 had a count of 8. So now we have our 5 bars. And one thing you might have noticed is you might ask, well, why is this in a bar chart form as opposed to a histogram form? Since this is quantitative data, why aren't these 5 bars touching each other? And the reason for that is we have now placed these groups out of order. And so it wouldn't necessarily make sense to connect going from 40 plus to 20 to 29 and from 30 to 39 to 10 to 19. It doesn't really make sense to put those bars touching each other so that it's like a kind of like a transition. Now we can kind of separate them into bars, and that is why we have them like this. And so now we have our bar chart portion, but what about the cumulative frequency? So this we're going to denote with a line that goes up and above all of the bars, eventually resting at 100%. So cumulative frequency for the first bar, the 40 plus, if you recall, was 30%, or it should be 30% because that was its relative frequency. And so we'll start with a dot right in the middle of it. And over here, that would denote about 30%. And now we now move on next to the 20 to 29 group, which had a relative frequency of 24%. And so the cumulative frequency at 20 to 29 is about 54%. The 54% would be about here. And so we would take a line that goes up to 54% and ends with a dot right over that 20 to 29 group. And so then we'll continue this for 30 to 39, which is an additional 21%, which brings us to 75. And then draw our line going up a little bit more to 75%. And then we'll now have our 10 to 19 group, which brings us to 89%. And so that dot will go about right here. Draw another line connecting that one. And lastly, 0 to 9 would rest at 100%. And so now we have our Pareto chart. And you'll notice whenever you make one, the line that we make for the cumulative frequency is always going to be kind of a hill, like a sloped sort of line that goes like this. And that will always appear to be the case because we always start with the largest relative frequency and move in descending order. So over time, the line will end up flattening out because it represents a smaller relative frequency as opposed to the last bar. And we can actually get this relative frequency just by looking at the chart, by finding the difference in the dots from one dot to the next. These over here represent all of our relative frequencies. And so a quick fun fact, and you can kind of gather this by looking at the Pareto chart, but any histogram or bar chart of counts should look identical to one of relative frequencies, meaning that if we have any bar chart, say this one, for example, about ducks taken from the park each day. As we all know, ducks are free to take from the pond. This is just one local park near my house. We have a number of ducks taken on the x-axis, and on the y-axis we have however many days that number of ducks was taken. And so this is just a contrived example. But if we were to try to graph the relative frequency, we'll find that it looks the exact same. And so in this case, if we add up the counts using the graph, we have 2 plus 4 plus 3 plus 1, which is 10. And so if we were to get the relative frequencies, this first graph, which has a count of, this first bar, for example, I should say, that has a count of 2, would have a relative frequency of 20%, 2 out of 10. And we would repeat the process for the other 3 bars and see that in the end, the graph will look the exact same. It'll have the exact same proportions as the previous one that listed just the counts. And this will work as long as we have linear scaling. You can also see from the Pareto chart the same deal. This is why we are able to graph the count on the same axis as cumulative frequency, is because of this property. Otherwise, we wouldn't be able to graph both of them on the same plot, and we'd have to break them up into 2 different plots.